Hi, and welcome back to API Can Code's third unit, Data Science Practices, and today's lesson, Graphs and Figures for Two Variables. We start with a warm-up, looking at the priorities of sort of late high school students and recent college graduates and how those compare. We hope that this will be engaging content for our population of mostly high schoolers, and particularly this course often gets taught with slightly older high school students, so hopefully this is pretty pertinent to their interests. We're going to recap lesson 3.3, which was all about using CodeApp to create data visualizations in one variable, including such visualizations as dot plots, histograms, and box plots for quantitative variables, and bar graphs for qualitative variables. Today, we're going to build on that understanding by creating graphs and figures in two variables, usually to display relationships. So first things first, students are going to open the roller coasters dataset and look at what kind of data this is, what's going on, what do they notice, and what do they wonder. Students have briefly looked at this data set before, I think 2 lessons ago. This is the example that they use to look at map data. So first, we're going to have students create a graph with max height on the x-axis and top speed on the y-axis. This should create a scatter plot with a positive trend for them. It is a roughly strong, or pretty strong correlation there in a positive direction, and it's a roughly linear shape. We want students to talk about all these different features of the graph, so we put them specifically on this slide, thinking about what is the direction. Obviously, that's positive. The form, this one looks mostly linear. You might argue that there's a bit of a curve to it, sort of a root function-esque slowing down. And the strength of the relationship, I would say, is pretty clear, not super cloudy. There may be outliers, but most of the points seem to mostly fit the pattern of the relationship overall. So we dive into a couple of these concepts in slightly more detail, going over first direction, meaning positive association, negative association, or neither. We talk about form, either linear or nonlinear. Talking about strength, here we get a little bit more into R values and some particulars, emphasizing that for students, the correlation coefficient can range from -1 to +1, with an R value being near +1, meaning a strong positive correlation, and an R value near -1, meaning a strong negative correlation. R values in the middle are obviously going to be sort of less strong or non-existent correlations. As far as outliers and scatter plots, these can be a little harder to recognize than outliers in one variable relationships. We are generally looking for points that don't fit the overall pattern of the graph. So points might be unusually high or low compared to the rest of the scatter of points. So for example, in the graph to the right, you see that red point should probably be somewhere around 10 or 20, but is in fact up near 60. So this is a pretty clear outlier, and students should consider removing these kinds of points from their data sets. Okay, we're going to go back to our roller coasters example and do a couple more things. First, we're going to add a third variable. Students can drag drop, length, type, year opened, or age group variables onto the middle of the graph to color the points. And this should show them a pattern in the data, or in some cases, not much of a pattern. But it is usually pretty interesting to see sort of the distribution of different colors through the graph. Next, as shown in the GIF to the right, students are going to click on the ruler icon and add a least squares line to the graph. This will also display the equation of the least squares line with a slope and an intercept. Students might notice that the slope goes with the variable and the intercept is the number that is not paired with the variable. It's important anytime we fit a trend line to think about, does the slope make sense? Does the intercept make sense? If they do, what do they mean? Generally, the slope is going to be the unit change in y associated with a 1 unit change in x. The intercept, on the other hand, is going to be the predicted value of y when x is 0. Sometimes those numbers make sense in context. A lot of times they don't. For example, a roller coaster that is, say, 0 feet tall does not really make any sense. So an intercept in that case would also be sort of nonsensical, because what is the top speed of a 0 feet tall roller coaster? It simply doesn't exist. Next up, we're going to have students create a new graph. This time, age group will go on the x-axis and type will go on the y-axis. Students might notice this obviously does not create a scatter plot. And we want them to recognize that the difference in the variables here is that the variables are qualitative instead of quantitative. So CODAP won't create a scatter plot because it doesn't have those continuous variables it needs to make a scatter plot. Instead, it makes a two-way binned dot plot. So the next thing we're going to do is some work with this dot plot. Students should click on the ruler icon, then show %, and finally select the row button. So this should show them the percentage within each cell grouped by that row. The student should interpret the 34% number in the top right box, which indicates that 34% of the data in that top row is in that top right box. Now students are going to go back to the ruler icon, leave show % selected, but select column instead of row. So this should flip the percentages to being by column instead of by row. This will change the number in the top right box. It'll now be a higher percentage of that last column than it was of the top row. Based on this data, ask students if they see a relationship between age and type of coaster, and maybe how they think that relationship is being shown. If there is a relationship between age and type of coaster, we shouldn't see exactly the same distribution of percentages across the table. Instead, there should be some kind of difference there. Moving on, we're going to put age group on the x-axis and type on the middle of the plot. This should color all the points, and what we're going to do now is click the graph icon, fuse dots into bars, just like we've done before with a histogram, but now we're going to go back to the graph icon and scale by percentage. So what this is going to do is set every bar total with type differentiating pieces of that bar. It's going to set them all to 100% in terms of height. So they should all be the same height at the end of this. And what students will be able to glean from this graph is what percentage in each age group are made of a certain material. Generally, students find it easier to answer the question about steel versus wooden coasters over time with this graph rather than the previous, because this graph clearly shows sort of the percentage of steel coasters in each age group and how different those are. The next few slides have a few examples of scatter plots that you can review with students. In each case, it's good to ask about the direction, the form, the strength of the relationship, and whether students notice any potential outliers. You could do a couple of these, you could do all of these, kind of depends on how much time you have, what you think is appropriate for your class, and what you want to do. We continue with a graph on Steph Curry and other players in the NBA. And finally, comparing GDP per capita in different countries to life expectancy in 2021. Notice that this graph in particular has a really strong sort of nonlinear shape to it. So this is a useful example to show students what a nonlinear form actually looks like. For our exit ticket, we've got two big questions for students. First, we want them to describe the direction, form, and strength of the scatter plot, including are there any suspected outliers? And secondly, we want them to look at this table on the right and think about whether they see a relationship between pre-med major and year. In terms of the scatter plot, most students will probably say that this is a moderate strength relationship, clearly has a positive direction to it. It is mostly linear, and there does seem to be one outlier around x equals 90 that is far below where it should be in terms of the pattern. For the second question, students might notice that that percentage changes year to year, suggesting that there is some kind of relationship between pre-med major and class year. In fact, if you look at the table, it seems to be decreasing as students go through sort of their college career. Thank you very much for watching this lesson walkthrough, and as always, thank you for teaching the API CAN code curriculum.